Okay, first question, nice straightforward integration. What we want to do is essentially think about splitting up this fraction. So we have x squared over 2x cubed minus 5 over 2x cubed. And then what I can do is I can do a little bit of cancelling. 2 of this x's will go with 2 of the x's there, just leave me 1 over, and there we have it with the cancelling. So looking at this first one, if I split the integrations up just to make it a little bit more obvious for you guys, I've got essentially integrating a half with the x on the bottom minus we're integrating 5 over 2x to the minus 3. Now I'm taking extra steps here, but what I would actually do is I'd be taking these constants outside. Okay, that is just to make your life so much easier. So this is the step I would jump straight down to. Okay, so from here it's nice and easy. So we've got a half integrating 1 over x. That's x to the minus 1. Okay, so that will mean we've got an ln x. And we've got minus 5 over 2. And then x to the minus 3. I need to add 1 to the power. So x to the minus 2. And divide by that new power. So we've got a half ln x plus 5 over 4 x squared on the bottom. So I'll write that over here, plus c. So that was a half ln x plus 5 over 4x squared plus c. Obviously, if you still left it as x to the minus 2, 5 over 4x to the minus 2, that would be fine as well. So first one we're looking at here is sketching 3f of 2x. So when I'm looking at this, the 3 is going to stretch my y values by a factor of 3. And the 2 inside is going to stretch my x values by a factor of a half. So that's affecting the x, and this one's affecting the y. Now, the shape of the graph will look the same. It's on a separate set of axes, so you can just pretty much copy the shape of the graph. And all you need to do is get right your values. So my x values are going to be cut in half, and my y values are going to be tripled. So these will then be my values. So like half of 1 is obviously a half, and 2 times 3 is 6. And obviously 0, 0 is going to stay the same. So the second one we're looking at is y equals f of minus x, then minus 1. So this is inside, it affects the x. We're timesing or dividing by negative 1. So we're multiplying all the x values by negative 1. So that means it's going to be a reflection in the y-axis. Because if you multiply all the x values by minus 1, the positive x values become negative, and any negative x values become positive. After that, then we also need to look at this minus 1. This is going to be a translation, a movement. And it's in the y direction, and it's by minus 1, so we're moving it down in the y direction. So again, a little sketch. We need to think about it going through minus 1 instead of the 0. And what I'd be tempted to do is even draw yourself a nice faint line through that through that minus 1, just to help you draw it. So the graph is going to come up as if this is now my axis, and I'm going to keep going up. I'm going to come down to hit this point, and then we're going to go back up. So we've got that reflection and then that movement. So we've lost 1 from our y, and our x has become the negative version. So -1, 1 for this one. Obviously I've already put in that we're hitting the y-axis at -1. And when I think of this point here, we've moved it into -3 and then brought it down 1. So -3, 1. Now we don't have the information to find these points here, and nor does the question ask for it. It wants the y values and it wants the maximum or minimum turning points. So we're done. Okay, so this first one now we need to, for part A, put these together as a single fraction. So where I'd like to start is by factorizing. So I want to look at factorizing this third part here. So in particular the 2x squared minus 3x minus 5. So I'll do that up here on the side, 2x squared minus 3x minus 5. I've got to have a 2x and an x. It's the only way in which I can solve it. I need a 5 and a 1. Again, the only scenarios that work. So we've got 5 here and 1 here. That should get me the 3. So we've got -5 and the +1. That then gives me 2x squared. 2x minus 5x is minus 3x, and this is my -5. So now I've got 5x plus 26 over 2x minus 5 and x plus 1. And I could have guessed at the x plus 1 because we got it here, and often we get something that is nice and easy to deal with like that. Now it's a matter of putting them all over 2x minus 5 and x plus 1. So that will be 3 times both brackets. So 3 times 2x minus 5, x plus 1, minus, and then we've got the x minus 2. That will just be multiplied by 2x minus 5. And then we've got the 5x plus 26 at the end. Now I'll just go onto a fresh piece of paper for this, and here we have it written out nicely. So now it's just about expanding everything that's on the top and simplifying. So we've got 3 lots of, now we already know what these 2 brackets are going to be, so actually I can just probably jump straight into 3 multiplied. So 3 multiplied by 2x squared is 6x squared. 3 multiplied by -3 is -9x. And 3 multiplied by the -5 is -15. Minus, and then I'm going to expand these 2 brackets, keep them into a bracket first, so we get 2x squared minus 5x minus 4x plus 10, and we've got the plus 5x plus 26, and of course that's all over 2x minus 5x plus 1. Now I can sort out a little bit of simplifying here. Obviously this minus 5x and minus 4x is minus 9x. So we've got 6x squared minus 9x minus 15 minus 2x squared plus 9x minus 10 plus 5x plus 26. So all I've done is get rid of that bracket which has the minus outside. I'd always have that bracket though because I don't want to make a sign mistake during this. Now we've got 6x squared minus 2x squared, 4x squared. We've got minus 9x plus 9x will cancel out, leaving me with just that plus 5x. And then we've got minus 15 and minus 10 is minus 25, plus 26, so that's going to be plus 1. And this is over 2x minus 5, x plus 1. Now I need to factorize this top, which hopefully shouldn't be too difficult. For the x's I could have 2x and 2x, or 4x and 1x. And looking at this, it's going to be 4x and 1x, and that is because I need a 1 in both, and these are going to have to be positive. So this gives me my 4x squared plus 4x plus 1x is plus 5x, and then plus 1. So 2x minus 5, x plus 1. Now you can see the x plus 1s cancel, leaving me with my final answer, which is this 4x plus 1 over 2x minus 5. So 4x plus 1, 2x minus 5. Where you can now see that A is 4, B is 1, C is 2, and D is negative 5. Okay, now part B is to find the inverse of this. So we want to make y equals 4x plus 1 over 2x minus 5, multiply by the 2x minus 5, expand my brackets, 2xy minus 5y, and then I need to get my x's onto one side. Doesn't matter if I go left or the right, the answer will basically be the same, but with one of the sets of signs switched around. So I'm going to go to the left and put it just up at the top right, so we get 2xy minus 4x equals, now we have a positive 5y plus 1 on the right. Factorize out my x, gives me 2y minus 4. Now, some of you might be thinking, why haven't I factorized out the 2 as well? Well, I don't want to, I just need the x. I have to only have the x, so factorizing out the 2 doesn't actually help me. Now divide by this bracket, so I get 5y plus 1 over 2y minus 4, and then we are done. Okay, so my f, the negative 1 of x, is 5x plus 1 over 2x minus 4, or I could write it as 5x plus 1 over 2 brackets x minus 2. It's up to you, they both will be correct. Now part C, finding the domain. Well, we know one potential value that cannot exist. So if I look at the bottom here, first thing I want to think about is that actually 2x minus 4 cannot equal 0. That's my plan. So when it equals 0, if I divide by 2, so I can now categorically say that x should not equal 2. So that's one thing just to take in for this one. And if I think about the top, I'm looking at the domain of f to the minus 1 of x. So I can also think of the values of the range of this f of x. So one thing I can think of is that since I want the values of where x is greater than 4, let's look at what happens when x equals 4. So when x equals 4, f of 4 will equal 4 lots of 4 plus 1, 2 lots of 4 minus 5. So that's going to give me 17 on the top and 3 on the bottom. So that's going to be at one of my limits, or it should be at one of my limits. Now let's have a look as 4 increases. So as x tends towards infinity. Okay, let's look at what's happening to my f of x. Now on this one, what I like to do is divide top and bottom by x, so that will give me 4 plus 1 over x, 2 minus 5 over x. Now as x tends towards infinity, these these fractions will disappear. 1 over infinity, pretty much 0, 5 over infinity, pretty much 0. So these will disappear, just leaving me with 4 over 2. And since 4 over 2 is 2, that will be my other limit. So I'm heading from 17 over 3, and I'm heading towards 2. But I'll never reach either of those values. So that's the range of f of x, and the range of f of x is going to be the same as the domain of the inverse of f of x. So we're looking at being less than 17 over 3 and greater than 2. Okay, but not equal to either of them. Okay, part A is nice and easy here. We need to find this point P, find essentially the x coordinates and then the y coordinates. Now, if I look at my f of x, this is 3x plus a in a modular sign plus a. This modular sign will always be positive. Okay, so that means that if there's any value in this, it's going to be positive, which means it's got to be higher up on my graph, which means we actually want this when the modulus equals 0. That will give us the smallest point, the minimum point. So 3x is going to be minus a, so x is minus a over 3. And clearly when that is 0, f of x is just going to be equal to a, so that is then my y coordinate. So minus a over 3, a is the coordinate of P. Okay, part B, g of x equal to mod x plus 5a. So this is going to be only positive, so it's going to stay above the x-axis. Its smallest value will come when inside the modulus is equal to 0, so that'll be when x equals negative 5a. So if I think of on the actual graph, it's going to be over there somewhere, negative 5a. It's going to have the gradient of 1, so it's not as steep as the other graph, and it's going to cross the y-axis at 5a. So like I know that this is going to cross at 2a, it's going to cross somewhere up there, it's going to cross at like 5a. So that's what I'm looking at. So when I think of my sketch, it's going to look something like that. This is going to be negative 5a, and this is going to cross at 5a. And I know this crosses at 5a because this is when x equals 0, and x equals 0, g of x equals 5a. So these two graphs intersect, and looking at my intersections is quite important here. So I can see that it's these 2 points. So I can see that the g of x graph, I only want the positive version of it, so x plus 5a, and the f of x graph, I'm going to want both the positive and the negative version. So I want 3x plus a, and then my second equation is going to be minus 3x plus a. And these are the two then that will give me the coordinates that I need. So a little bit of rearranging, and you can see 2x is going to equal 3a. So x equals 3 over 2a. And then with the second one, I need to first expand the bracket. Okay, and then you can see if I rearrange, I get 4x on the left minus 5a on the right. So x is minus 5 over 4a. Now those are the x values. I need the y values to go with them. Okay, so I need to use one of my equations, either the f of x or the g of x. Now, since I'm using just the positive g of x, it makes a way more sense to substitute the values into that one. So y equals 3a over 2 plus 5a, which is 13 over 2a. And then y equals negative 5a over 4 plus 5a, and that is 15 over 4a. So my coordinates are 3 over 2a, 13 over 2a, and minus 5 over 4a, 15 over 4a. It's often easy to forget the values of y and just to leave it with the values of x, so just be careful there. So part A, nice and easy here. We get theta equals a minus 180 e to the kt, where that is negative, and a and k are positive constants. Given that the temperature inside the oven is initially 18 degrees, that will mean that theta equals 18 while t equals 0. So 18 equals a minus 180. So a is equal to 198. And that's part A done. So when time is 5, the temperature is 90 degrees. So using my formula, I can substitute it in. Now obviously the minus k times 5, it'd be much better to write this as minus 5k. And the theta is 90 degrees. So let's pop that in. So rearranging, 180 e to the minus 5k is equal to 108. E to the minus 5k equals now 108 divided by 180 is 3/5. Now what I want to do is take logs of both sides. So this becomes minus 5k ln e, or minus 5k, and divided by the minus 5, and we have k equals minus 1/5 ln 3/5. Now you could write k as 1/5 as in positive and 5 over 3 as an alternative, but I'm not going to, since there's a minus k in the question, in the formula. So I'm going to leave that take care of the negative in this part. So here we now have our formula, and when t equals 9, we just need to substitute that into our new formula. And here we get 126.2, and it wants it to 3 significant figures, so 126 degrees Celsius. Okay, and then finally part D is a rate of change in temperature. So we want to find d theta by dt. So the 198 is going to go, and then we've got minus 180 e to the t over 5 ln 3/5, and we need to multiply by this differentiated? Well, this is a single t and this is just a number, so this is the number we're going to end up multiplying by. So we're going to multiply by 1/5 ln 3 over 5. So that is going to be minus 36e to the t over 5 ln 3/5, and we're still times in by ln 3/5. And then we want it when t is 9, that's in the question here. So d theta by dt equals 7.33 to 3 significant figures. Right, this is a function times a function. So to differentiate this, what I'm going to do is let the first one be u and the second one be v. So u equals x and v equals cos x over 3. And differentiating each of these, I'll get du by dx is 1 and dv by dx. Now cos differentiates to negative sine, and then we also need to multiply by this differentiated, which is a third. So we got negative 1/3 sine x over 3. So my differential is u times dv by dx, so these two multiplied. So that's minus 1/3 x sine x over 3. And then du by dx, or v times du by dx. So it's 1 times this cos, so we got plus cos x over 3. Or a nice way around to write it would be the cos first, minus the sine part. So part B is a show that we need to make this equal 0 and then rearrange. So this shouldn't be too difficult, just going to make a little bit more space. Okay, so it tells me that this equals 0, so that means that cos x over 3 minus 1/3 x sine x over 3 equals 0. So first take my sine to the other side, so we get 1/3 x sine x over 3. And I want to turn it into tan, so I'm actually going to multiply by 3, divide by x, which is these two here, and then I'm going to divide by the cos, which will give me sine x over 3 over cos x over 3. So this then gives me 3 over x equals tan x over 3. Now you can see we want arctan. So arctan is the inverse of tan. So when I take that, I'll get arctan 3 over x equals x over 3. I'm multiplying by 3, so 3 arctan 3 over x equals x. And there it is rearranged. So part C is all about substituting into my calculator. So the first thing I want to do is start with 2.5. So what I will do there is I put 2.5 into my calculator and I press equals. And after that I press the AC button. That's then stored in my calculator as the answer. I then need to set the rest of my calculator up. So I'm going to do 3. And then for the arctan I need to do shift tan. And then I want to put 3 over answer. So in mine I'm just doing 3 in this fraction button, and then answer on the bottom, and then I'm going to press across and close my brackets. So it should look something like this in your calculator, if you've done it right. Okay, you can obviously replace this with a divide sign, would work just the same. Now, since this is x1, when I press equals, I'm going to get x2. And x2 is then 2.628. Okay, and that's the first one we want, and then we want x6. Now I'm just going to write the next few down up to x6, but obviously you don't need to do this. So one more press will give me x3, another press then 2.597, and then we've got 2.572, and then finally 2.586. And then obviously these are the two answers that we require. Okay, just make some more room. And the final part, part D, says that when f of x is equal to 0, or the differential of x equals 0, the root is 2.581, corrected 3 decimal places. We need to pick a suitable interval, so we want to go just above and just below. So we want to go to the 4th decimal place. So 2.5815 will be above, and 2.5805 will be the one below. And the idea is that this will round to 2.581 to 3 decimal places, and this one pretty much does. I know the 5 technically doesn't, but if I had a 4, 99999999999 and so on forever, it is going to be the same as this for my calculation. So it makes no difference. Now remember my answer to part A, which was cos x over 3 minus 1/3 x sine x over 3. So that's what I'm doing, and I'm just going to substitute both of these x values into this equation. So here I get negative 0.00035, and then with the second one, which is 2.5805, I get 0.00035, pretty much the same there. So you can see now I've got a change in sign, therefore there should be a root between there since this graph is continuous. So I'm just going to put it in basic here. So this is what we're looking at: sign change and continuous. Okay, the continuous part is just to show that it is one line, one graph, and it's not like a reciprocal graph, like a 1/x graph, so, which wouldn't be continuous. So that's why you want to put in the continuous. So you want sign change, continuous, therefore root, and just make it into a nice sentence. Okay, part A is prove that. So we want to start with one side. So I'm going to start with the left-hand side. So we get sine 2x over cos x plus cos 2x over sine x. So sine 2x is 2 sine x cos x, and that is over cos x. Now with the second one, since there's a sine on the bottom, I'm going to use 1 minus 2 sine squared x. Now this might not work, but with the sign on the bottom, hopefully it will. So I can see and cancel these x's there, which is nice. So that leaves me with 2 sine x on the left bit. Now when I look on the right, I'm going to split these up. So 1 over sine x here minus 2 sine squared x over sine x. And one of these signs will cancel there. Oh, now look, I've got 2 sine x and I've got a minus 2 sine x. Those are going to cancel with each other, aren't they? Leaving me just carry on up here 1 over sine x, which is cosec x, which is my right hand side, and hence proved. And if you wanted to, you could have put the extra line in there, just the 2 sine x plus 1 over sine x minus 2 sine x, if you wanted to, but you wouldn't have needed to. So now we have hence solve. So that means we should use our answer to part A, or certainly what's already given to us in part A. We don't have to, but usually it means it's easier. So let's have a look. So we want sine 4 theta over cos 2 theta, so essentially x is going to be 2 theta. So if I take this original one here, and we're looking at sine 4 theta over cos 2 theta plus cos 4 theta over sine 2 theta, that's going to be equal to cosec 2 theta, because we've got x being equal to 2 theta in there. So that's what we can initially replace in here. So 7 plus cosec 2 theta equals 3 cot squared 2 theta. Now, cot squared is linked to cosec squared. Remember that, and again I'll put this in red at the top. We know that 1 plus cot squared x equals cosec squared x. So I know that cot squared can be replaced with cosec squared minus 1, and that is what I'm going to do. So 3 lots of cosec squared 2 theta minus 1. And then I've got the 7 plus cosec 2 theta. Rearranging and making equal to 0, I'm going to have 3 cosec squared 2 theta minus cosec 2 theta. I've got a minus 3, and when I take the 7 over, it's going to be minus 7, so it's going to give me minus 10 in total. So just moving up here, we want to factorize this. Okay, so I'm going to go straight in with it. So we got 3 cosec 2 theta and a cosec 2 theta. And I'm going to be looking at 2 and 5, because 2 3s are 6, and 6 take away 5, or 5 take away 6 is what I'll actually want there. So I want 5 take away 6, so that's going to be my setup. And just checking, 3 cosec squared minus 6 plus 5 gives me the minus 1, and 5 times negative 2 gives me my negative 10. And of course this equals 0. Just move it across a little bit. Equals 0, squeeze that in. Now I'm going to take this to a nice new page so we can solve the final bits. So from here we have 3 cosec 2 theta plus 5 equals 0. So cosec 2 theta equals minus 5 over 3. And the other one would be cosec 2 theta minus 2 equals 0, or cosec 2 theta equals 2. Remember, cosec is 1 over sine. I'll do it with this one in full. So that means that sine 2 theta is minus 3 over 5. Well, in this case, sine 2 theta equals 1/2. So this is where I'm at, and theta is between essentially 90 degrees and negative 90 degrees. So personally here, I like to change the 2 theta. So x equals 2 theta. I always do this when that angle is not just a single angle on its own. And that will also mean that I need to change my range. Now I've got the range, so we're looking at sine x equals minus 3 over 5. So x equals, and this will give me my calculator, minus 0.644. And of course I will store this in my calculator, or certainly store the positive version of my calculator for use. So thinking of my cast rule, here is my cast. My 0.644 will be there, and we want to go from minus 180 round to plus 180. Okay, so going in the positive direction from 0 round to pi, I only have sine being positive and positive, and clearly here sine is negative, so I get no answers between 0 and pi. Now going in the other direction, I'll do this in red, so going from 0 round towards the negative pi, sine is going to be here and here, so it's going to be in both sections. So this one, the minus 0.644, we already have, and then I've got this one here, so this is going to be minus pi plus 0.644, and this second angle will be negative 2.498. And again, I'm going to store that in my calculator so that I have two full answers, so that when I do find theta, I can nice and easily. Now, we do have the other sign to work out, but let's work out the theta here first. We know that x is equal to 2 theta. So x equals 2 theta, and that equals my minus 0.644 and my minus 2.498. So theta is going to be these divided by 2. And here we have them negative 0.322 and negative 1.25 to 3 significant figures. Now we just need to find the other set of angles. And here we have, just setting up as before. So sine 2 theta equals 1/2. When we let x equals 2 theta, we get sine x equals 1/2. Therefore x equals pi by 6. And then if I go to my cast diagram, again I'm going from 0 round to pi, and then I'll go 0 round to negative pi. Now, just the same as before, this time sine is positive. In this direction, sine would be negative, so we have no answers between 0 and negative pi. In the positive direction, we have an answer here, which is our pi by 6, the first one we found. And then we have our second answer here, as sine is also positive here. And since this is pi by 6, we have pi minus pi by 6. So that means our two values of x are pi by 6 and 5 pi by 6. And remember that this x equals here is also the 2 theta equals. Therefore 1 theta will be pi by 12 and 5 pi by 12. So my final answers for theta are pi by 12 and 5 pi by 12 for the two positive ones, and then negative 3.22 and negative 1.25 for the two negative answers in this case, and 4 answers in total. So P equals ABT. I'll do this from scratch, but you don't have to. Take a log to the base 10 of both sides. Bring the t down. And there we essentially have it. Okay, if I just rearrange slightly, we get log b t plus log a. And this is now y equals mx plus c. So you can see our gradient is log b and our y-intercept there is log a. That means that log b is equal to 0.09 and log a is equal to 0.68, and we get that from the question. Now it actually asks us to find the values of a and b. So remember that these are logs to the base 10. So a is going to be 10 to the power 0.68 and b will be 10 to the power 0.09, which of course we can work out. So 4.79 and 1.23. Correct the 2 decimal places as required. And a pretty easy 4 marks. Now part B, I'll pop over here. It asks me, in the context of the model, give a practical interpretation of the constant A. So if you think about it, when t equals 0, that's what we get. That's when t equals 0, which means that this is the year 2005. And since P is the percentage of the population who have access to the internet, this is simply the percentage of the population who have access to the internet in 2005, or the start of 2005. And there we go. So part C now says to use this model to estimate the percentage of population who had access to the internet at the start of 2015. So the start of 2015 is going to be year 10. So it's just a matter of substituting that in to this formula with our values of A and B. And we're looking at an answer that rounds to 38% there. Okay, question 9, we've got these integrations. Now, it's only worth 2 marks, so it's got to be quick and easy. If I look at it carefully, the bottom differentiates to give me something very close to the top. So that's where I want to start with, the bottom. So think of a rough integration for the bottom. And a rough integration will be ln 3x squared minus 4x plus 5. I'm not trying to integrate properly, just a rough integration. And then if I differentiate this, I get 1 over 3x squared minus 4x plus 5 multiplied by the inside differentiated. So that's 6x minus 4. So what you can see is that 6x minus 4 is double the size of this. So this is the same as 2 lots of 3x minus 4 over 3x squared minus 4x plus 5. So to get this answer the same as this, I need to divide this by 2, which means that this answer will also be divided by 2. So what I'm actually looking to do is divide by 2. So So that means I'm adding in that half there. So my answer here is a half ln 3x squared minus 4x plus 5 plus c. And we're done. Remember, we just did a rough integration, which gives me this. Differentiated gives me this, which means that if I integrate this, I would get this. So if I integrate half of this, I will get half of this. Again, the second part is, as we can see, just 2 marks again. So again, we're going to do a rough integration. Now, think of this as being on the bottom, e to the 2x minus 1. If I put it to the top, it'd be minus 3. So a rough integration would be adding 1 to the power. So we get e to the 2x minus 1 minus 2. Now when I differentiate this, I get minus 2 e to the 2x minus 1 to the minus 3 multiplied by, now I need to differentiate this middle. Differentiating e to the 2x will be 2e to the 2x, 2e to the 2x, and the minus 1 differentiates to nothing. So now you can see I've got minus 4e to the 2x on the top, and if I take this bracket down, I get e to the 2x minus 1 cubed on the bottom. Now, when I'm comparing this with my original, you can see this is multiplied by minus 4. So what I want to do is, and you guessed it, basically divide by minus 4, which means that I need to divide my original by minus 4 here. So this answer is going to be minus 1/4 e to the 2x minus 1 to the minus 2 plus c. Or a slightly better way might be, I've got minus, I've got 1 on the top, and I've got 4e to the 2x minus 1 squared plus c. And that might be a nicer way of writing it, but equally both are correct. So we have x equals 3 sec squared 2y, or a nicer way would be x equals 3 sec 2y squared. So differentiating, I get dx by dy multiplied by my 2, so 6 sec 2y to the power 1, and then I need to multiply by the inside of the brackets differentiated, so sec differentiates to sec tan. Okay, and that would also be multiplied by 2 because of the 2y. So it should have been 2 sec 2y tan 2y. So in total I get 12 sec squared 2y tan 2y. And that's part A done. Okay, part B, we need to show that dy by dx is equal to p over qx root x minus 3. Okay, so first thing I can see is that we already know that x equals 3 sec squared 2y. Okay, and I can get that from here. So if I take from the 12, so we've got 4 lots of 3 sec squared 2y tan 2y, then this gives me 4x tan 2y. Now, from this one, we've got x equals 3 sec squared 2y. Sec squared is 1 over cos squared. So this is going to be the same as x equals 3 over cos squared 2y. So cos squared 2y is equal to 3 over x. Now that means that since cos squared is equal to 1 minus sine squared, 1 minus sine squared 2y is equal to 3 over x as well, or sine squared 2y is equal to 1 minus 3 over x. Now, before I square root, let's think about putting these together. So sine squared 2y divided by cos squared 2y is going to be 1 minus 3 over x over 3 over x. So that means I get tan squared 2y equals. If I make this a little bit nicer for you to see, the top one would be the same as x minus 3 over x. And then we're dividing by 3 over x, so that's the same as multiplying by x over 3. That'll mean these will cancel out, leaving me with x minus 3 over 3. And then I can take the square root of that with my tan. So that would mean that tan 2y is the square root of x minus 3 over 3. So substituting that in up here, I get 4x square root x minus 3 over 3. And now we're pretty much there. Okay, now I'm going to separate this out. So I've got 4x root x minus 3 over root 3. And that's because it's in a very similar form to what I want now, and I know that p is irrational. Now this is obviously dx by dy, so dy by dx will just be this flipped, so we get root 3 on the top, we get 4x root x minus 3 on the bottom. So that means that p is root 3, which is irrational, and q is 4, which was an integer as required. Okay, final part C. So we need to find the equation to the normal at the point where y equals pi by 12. So we can find our x value here. So 3 sec squared, and it's 2y, so 2 pi by 12. So 3 over cos squared pi by 6. And that will give me that x is equal to 4. So from that now I can find out my dy by dx, my gradient. So dy by dx is root 3 over 4 lots of 4 times the square root of 4 minus 3. So we get root 3 over 16. Now we want the normal, not the tangent. So the gradient of the normal is going to be change the sign and flip this. So using y minus y1 equals mx minus x1, we get y minus pi by 12 minus 16 over root 3 x minus 4. So y equals minus 16x over root 3 plus 64 over root 3 plus that pi by 12, and we need to rationalize this, so we need to times top and bottom of here and here by the root 3. So we're going to get minus 16 root 3x over 3 plus 64 root 3 over 3 plus pi by 12. And that's it done. Easy, 5 marks at the end there. Awkward numbers, but nothing too difficult.